Before we start anything, let's think about how we can solve this question. First of all, we need to identify the complex term of the question. In this function, the complex part is square root 2x plus 3. Now, we try to remove the complexity of this term. If we substitute u squared equals 2x plus 3, then we can simplify square root value of 2x plus 3 as u. After that, we can express simple x value in terms of u. Finally, we can change the upper limit and lower limit according to the u variable. Then we can simplify this integral. Clear? Let's jump into the question. Substitute u squared equals 2x plus 3. Then differentiation with respect to u. Differentiation of the u squared value we can write as 2u into differentiation of the u value with respect to x du over dx equals differentiation of the 2x we can write as 2 into 1. Differentiation of the constant value 0. Now we can cancel out 2 value and we can cross multiply dx value. After that we have dx value as u into du. Now we can express simple x value in terms of u. U squared equals 2x plus 3. Then u squared minus 3 equals 2x. X value equals u squared minus 3 over 2. Now we need to change upper limit and lower limit according to u variable. When x equals 11, u squared equals 2 times 11 plus 3. Then u squared equals 25. Square root value we can consider in the both sides. Then u equals 5. When x equal to 23, u squared equals 2 times 23 plus 3. Then u squared equals 49. We can consider square root value. Then u equals 7. Let's move to the integration part. Lower limit equals 5. Upper limit equals 7. Instead of x value, we can substitute u squared minus 3 over 2. Instead of 2x plus 3 value, we can substitute u squared. Instead of dx value, we can substitute u into du. We can consider a common denominator for the denominator value as 2. Square root value of u squared equals u. After that, we can cancel out numerator value u and the denominator value u. Denominator of the denominator value 2 we can write as numerator. Numerator value 2 is a constant, so we can bring this 2 value outside of the integral. Now we need to get integral 1 over u squared minus 1 value. U squared minus 1 value we can factorize using difference of u squared. It is equal u minus 1 into u plus 1. Now we have 1 over u minus 1 into u plus 1. To simplify this integral, we can use partial fractions. Using partial fractions, we can write this value as half over u minus 1 plus minus half over u plus 1. Then we can write this fraction as half into 1 over u minus 1 minus half into 1 over u plus 1. We can consider integral sign separately. 1 over 2 value is a constant. So we can bring 1 over 2 value outside of the integral. We can get half value as a common factor. After that we can cancel out numerator value 2 and the denominator value 2. Now we need to get integral 1 over u minus 1 and integral 1 over u plus 1. Integral 1 over u minus 1 equals ln modulus u minus 1. Integral 1 over u plus 1 we can write as ln modulus u plus 1. Finally, we need to substitute upper limit and lower limit for these answers. First one, ln modulus u minus 1. Upper limit 7, lower limit 5. Second one, ln modulus u plus 1. Upper limit 7 minus lower limit 5. We can consider the modulus value of a positive number as just the number. So in here, we can write ln 6 minus ln 4 minus ln 8 plus ln 6. We know ln a minus ln b equals ln a over b. So in here, we can write ln 6 times 6 over 4 times 8. After that, we can simplify this value and get the final result as ln 9 over 8.